Section 5.3, Probabilities using counting methods. So we're going to solve probability problems that involve counting techniques. So remember, we learned how to count from Chapter 4. So things like the fundamental counting principle, the permutations when order matters, combinations when order doesn't matter. So all of these things are going to come into play, but now we're doing probability. So probability means that we take all the favorable outcomes and we divide it by all the possible outcomes. Remember that probabilities always lie between 1 and 0. You either have a 100% chance of doing something, a 0%, or somewhere in between. You can't get a probability of 3. You can get a probability of 3/10, that's 0.3, which is in between. So all of these things are going to help. So we have Ari, Ben, Cam, and Dan, A, B, C, D, have each booked a flight to Florida. The airplane has 4 seats in a row, and they're planning to sit in the same row. What's the probability that Cam and Dan will be sitting in the same side of the airplane? Okay, so the first thing to think about is, does order matter in all the different cases? Well, yes, it does. So what we're going to do is we're going to figure out, we have 4 people. How many ways can you arrange them in 4 spots? That's 4p4, which is simply 4 factorial. So 4 times 3 times 2 times 1, which is 24. So that's our denominator, is 24. Now, how many of those cases has Ari and Ben, or sorry, Cam and Dan together? I guess it's the same as all the cases that Ari and Ben are together. Okay, so they are, how many ways can you put them together? Well, there's 2 seats that are together, and so we either have Cam and Dan or Dan then Cam. So there's 2 ways, but then there's also 2 different spots that they can be in, because it can either be Cam and Dan, Dan and Cam, or Cam and Dan, Dan and Cam. Okay, and with each of these ways, there's also 2 ways that the other 2 could be arranged. So what that means is, with this case, it can, in the other seat, there could be Ari and Ben, or Ben and Ari. So there's 2 times 2 times 2 ways. 2 times 2 times 2 ways. So 2 ways that they can be in each spot. There's 2 spots, but with each of those 2 ways that the other 2 can be arranged. So what that is that's 8/24, simplifying, that's 1/3. They have a 1 in 3 chance that they will be sitting together. Okay, let's look at a couple other examples. And all of the examples in your book are really good. Oftentimes, problems you do are similar to examples that have already been done, so don't be afraid to go back and read and understand examples in your book. Jamal, Ethan, and Alberta are competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that they will place first, second, and third in any order. Okay, so because order doesn't matter, we might think first of all that we're going to use combinations. And let's look at this solution using combinations. Okay, there are 3 choose 3 ways in which only these 3 runners place. So to do 3C3, we use the combination formula, or we just use our calculator and put 3C3 and say 1. There's 1 way to do that. Now the total number of ways is there's 10 people, and how many ways can you choose 3 of them? So either using the formula or using the button on your calculator, the 10C3 is 120. So we have 1 over 120 is our probability, which is roughly 83%. So that's using combinations. So how many ways can we combine? 3 choose 3 is 1, and then 10 choose 3, because there's 10 total runners. There was these 3 plus 7 other boys, so 10 choose 3 was 120. 1/120th. If you think different, if you think about permutations, there are 3p3 ways in which they can place. Okay, so there's 6 different ways. So that means we can have Jamal, Ethan, then Alberta. We can, rather, A-E-J. We can have J-A-E, E-A-J. We can have E-J-A, and A-J-A-E. All those different ways that they can arrange. There's 6 ways. The total amount they can arrange is 10p3, all the players. That's 720. So that's 6 over 720, or 1/120th. So we get the same answer depending what we're looking at. So which one's less work? That's what you have to think about. Well, for me personally, I would have used combinations because the question said in any order. So I would have done combinations. And I like working with 1/120th more than I like working with 6 720th personally. Okay, let's look at another problem. Okay, so Bo hosts a radio show in Saskatoon. Oops, I've lost my question. To advertise his show, he is holding a contest at a local mall. He spells out Saskatchewan with letter tiles, so with Scrabble tiles, he spells out Saskatchewan. He turns the tiles face down and mixes them all up. Then he tells Sally if she arranges the tile in a row, so she takes the tiles, and if she turns them over and it spells Saskatchewan, she wins a brand new car. What's the probability? Intuitively, I'm going to say the probability is probably going to be low because, you know, giving away a car is kind of an expensive prize. So people would rather not give away a car. So here's how to do this. Let's look at all the ways that we can arrange the letters Saskatchewan. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So this is permutations. But we have some repetition. We have 2 S's. I'm just going to cross them off so I see. We have 3 A's. Is there anything else that's the same? I think that's it. So 12 factorial over 2 factorial, 3 factorial. Those are all, we're only talking about unique ways. So nothing is the same due to those 2 letters. Okay? And they found that to be, I just didn't want to get out my calculator on here, 39,916,800. Okay? So how many ways can you spell Saskatchewan? Just one. And this is unique because some people say, well, no, there's one way, but then there's 2 S's and there's those 3 A's. So there's actually a bunch of ways. No, and the reason for that is we only considered the unique arrangements here. So of those unique arrangements where we didn't double count, only one of them spells Saskatchewan. So actually the probability that this person's going to get a car is 1 over 39 million. Okay, super rare probabilities. So winning the car is very unlikely. So the key ideas in this section is you're going to use the fundamental counting principle. If you have, remember that's the word and, then you're going to multiply whenever it's and techniques involving permutations and combinations to solve probability problems of many possible outcomes. The context of each particular problem will determine which counting techniques you will use. Always look if order is important. If order is important, you're going to use permutations. Order not important, you're going to use combinations. Okay, this is a section where you should be constantly checking your answer book to see that you're on the right page, looking back at examples, looking back in chapter 4 to see, okay, how did we do permutations when there was repetition?